This is day 2 of 7-6 where we're analyzing sine and cosine functions from an equation or a graph. I'd like us to look at this again. This time we're going to look at the key features. This is what we started this whole year with, key features of graphs. So when it comes to periodic functions, we have the period. In this case, the cosine, we would take 2 pi and divide it by 3. The amplitude would be here. There's no shift left or right, but there is an up one here. You may want to graph this, but I think you can remember that sine and cosine go on both ways, forever and ever, for the domain. Now the range is simply the maximum and minimum value. Well, how could I find that if I didn't want to graph it? How could I find it from just looking at the function? Well, we know that the largest that the cosine can be is a positive 1. So if we put 4, positive 1 plus 1, we would get 5. So that's the largest it can be. And it would include that. Now, the smallest that it could be would be a negative 1. That's the cosine function. So 4 times a negative 1 plus 1 would give me, negative 4 plus 1 would give me a negative 3. So that's the smallest it could be. That can help me graph it too, right? If I know those max and min values, it can definitely help me graph the function. So let's take a look again at the key features of this one and look at the graph. Now this one's a little different than the one we just did. This period, it's just 2 pi because I'm not multiplying x by anything. The amplitude is the absolute value of negative 3, so it's positive 3. And the horizontal shift is pi over 2, and it goes, because it's plus, it goes left. The vertical shift is out here, so it goes down 2. Now the domain is always negative infinity to positive infinity. The range is my min and max value. Now again, I could do that from the graph. This looks like a 1 here for pi and then 1. And then this would be my minimum. It'd be 0 and negative 5. So my range would be from negative 5 to positive 1. Again, you could put the biggest the sign could be would be positive 1. So negative 3 times positive 1 minus 2 would give me what? Negative 5. The smallest the sine function could be would be a negative 1. So negative 3 times a negative 1 minus 2, that's a positive 3 minus 2 would give me my 1. So notice the largest sine value gives me the minimum y, and the smallest sine value gives me the maximum because of that negative 3. Remember, it's a reflection. And your midline would be halfway between negative 5 and 1. So it would be right here at negative 2. There's something interesting that happens when we use that negative, that we use the reflection, and we use phase shifts. We can actually interpret a cosine to be a sine graph or a different kind of shift with it, up or down, left or right. There's all kinds of interesting things that can happen when you compare those. And you can play around on Desmos and your calculator to figure that out. So if I'm just looking at the function, it would be wonderful if I could just look at it and find out all this information. And then I could graph it just to kind of double check. And I'll show you, I think I'll graph this one on the calculator because I haven't done that yet. So the period, 2 pi, amplitude 1/2. Oh, that means, wait a minute, amplitude of 1/2, that's going to be really thin, right? The phase shift is pi over 3, and minus means I'm going to the right. And -4 means I'm going 4 down. Once again, the domain would be negative infinity to positive infinity. I could put my minimum in by doing 1/2. -1 is the smallest that a sine function can be. -4. So that would be -4.5. And then the largest it could be would be 1. Subtract 4 from that, and I'd get -3.5. Now I could look at these two values. Difference is 1, right? And divide it by 2, and I'd get 1/2. That's my amplitude. So you've got a lot of information you can get. Whoops, that should be a point. Just from this one equation. Let's go over to the MCA calculator, the freebie over here. I'll just add another one here. If you just type in, this is what I do, MCA calculator, and maybe your teacher gave you a link, but this is just as easy. Always go to the graphing calculator for 8th to 11th, and you're going to sign in as a guest. It'll just sign you in as a guest. Pretend you're starting the test and just hit the calculator. All right, so I'm going to type this one in because it's a little different than the ones we've been doing. So I'm going to do 0.5 for 1/2. And then I would do times the sign, and it always puts the parentheses in there automatically. X is this up here, minus sign, not the negative sign, the minus sign, and then pi is over here. So second up arrow gives you the pi, and we're going to divide that by 3, close the parentheses, then subtract 4. Now before I graph it, I'm going to look at my mode. I'm in radian modes. You'll want it in radian modes now. So let's go back. Everything looks good. I'm going to hit the graph and see if my window is set up right. Oh, yeah, my window's not too bad. I could zoom in a little bit if I wanted to, but I can see up there how I'm getting quite a few cycles, right? So there's a period, there's another period. So good. I can kind of gauge to see 1, 2, 3, 4, 5, 6. All right, a little more than 6 because we said it was. Let's go back. Which one did I do? Oh, let me see. All right. 2 pi. Yeah, I was just checking. Make sure I didn't mess up there. So 2 pi is about 6.2 something. So yeah, that looks like I did that right, and it's very narrow. Good. I like to double check things with the graph. Why don't you try this one, write everything out, and then I'll come back. Do you get this? Do you remember from the previous video that when we have something in front of the x, that is our b, but if we're also trying to do some kind of shift, we have to factor out that b, and that makes it more accurate. So if we factor out the b, which is 2, that means this ends up being pi divided by 8, which might be a little different than what you're used to thinking about. So look at my equation here. A is my amplitude, that's 2. The period is always 2, and that would give me pi, right? And then the horizontal shift, because I factored out, this is my shift, that 2, the horizontal shift is now pi over 8 to the left. And this outside the parentheses is my vertical shift up 2. And the domain is always negative to infinity to positive infinity. The range, I always think of what is the smallest value of cosine? And if you look on your unit circle, the x, the smallest it is -1. So that's the smallest any cosine of anything could be is -1. So 2 times -1 is -2 plus 2 is 0. So that's my minimum right here. And then my maximum, the largest cosine could be, or the x coordinate could ever be, is 1, and that happens, straight up at at 0 degrees, when that whole thing is 0 inside. So the cosine of 0 is 1, and 2 times 1 is 2, plus 2 is 4. All right, so hopefully you got that correct. We could go check. Let's go ahead and look on the Desmos. I'll undo these two, and I'll do this one. And then I like to compare it to the same amplitude to cosine to x, and then I would go ahead and put the plus 2 in there afterwards, plus 2, so it's shifting it up, because I just want to see the phase shift. I don't want to see all the other changes. I just want to see the phase shift. So looks like a little Christmas tree there, huh? This is my original at 0.4, and notice this one went over just negative pi over 8. Yeah, see the peak there. Does that kind of help you a little bit? Hopefully it does. We'll go back to the, this is what we were working on. So hope that helps. All right, let's take a look at this little robot thing here. So there are a lot of robots in assembly line these days because they never get tired, right? You just keep working them over and over and over. But they need people that can operate and regulate these robots. So it's a field that's very up and coming. An assembly line machine stamps a company's logo on each product coming down the line. The graph models the stamp's height from the machine's axle. So this is probably the axle. Here's the height right now, and it goes up and down and up and down and up and down over a period of time. So time is the x, and then the equation models the motion. Oh, well, we want to find the equation. They gave us the output of what it looks like, and we want to see if we can find an equation from a given graph. Now this is a little different, so we're going to have to look at some things. In this case, the period one here all the way over here, it looks like it's about 2. I'd probably start at 3 and go over to here a little more than, okay, 309 something. So, what would you think the period would be for that? 6 something. So I would get about 2 pi, and that makes sense. We're going to assume it's a sine or cosine wave. The amplitude, well, it's just going up to 1 here and down to 1 here, so that's just a 1. The phase shift, well, it kind of depends if we're doing sine or cosine, right? And it's not exactly on 0 here, so it's shifted over just a little bit, a really, really small number. So the phase shift is just a small, little tiny bit. Not very much. So about, let's just say 0.1 to the left. And then the vertical shift, it's not going up or down because my midline is right on the axis there. So there's no vertical shift. Domain and range. My maximum minimum I can easily find from here. So I'd have a -1 all the way up to a +1. Now if I use the sine function, the sine of 0, remember the y value when the angle is 0 is 1, 0, so the sine of 0 is 0. So if we use the sine function, we have an amplitude of 1. We really have a pretty much straight up sine function. And we may want to do just a tiny little shift of some sort. And that's probably because it doesn't go down. all the way at the beginning, it's not all the way down. That's probably why. But something interesting is the sine and the cosine are just phase shifts of each other, and I want to show you that. I do want to show you that. I'll do it on Desmos. So here's the sine of cosine of x, and we'll just make this one the sine of x. And then we'll add something to it and see which way we have to move it. So where would I have to move this to get it to line up? To line up, let's see, about 1.6. It's half a pi is what it is. It's not quite there. There we go. That's pretty close. So when I phase shift a sine function just to half pi over 2, it will line up with the cosine function. So they can look the same. So if I show you a graph and I want you to make an equation from it, I'll probably tell you sine or cosine. For instance, on this one, I'm suggesting using the cosine function. That's where you're starting. So normally the cosine of 0 is the 1. So you can see then it just got shifted down, right? The cosine of 0 is normally 1, but now the cosine is, from this function, the cosine is -1. Cosine of this, well, how should I say this? When I do all this, so it started out at 1, and now it went down to -1. Let's make sure my amplitude is still a 1 before I start trying to figure out the other things. It looks like it is. And the period is still a 2 pi, so there's no phase shift, right? If I assume it's a cosine. But there is a vertical shift. It went down. Was it 1? It went 1, 2 down. So it went -2 or 2 down. So that's where this comes from. The nothing in front of here, nothing in front of here. Domain is still the same, like we've been doing. And the range is now, the minimum is actually a -3. The maximum is a -1. I could subtract those two and take the absolute value, and I would get +2 divided by 2, and the amplitude would be 1. Okay, I think we're done there. So we've got a lot of different things going on here. Again, play around with it as much as you can. Try some things. If you want to be real creative, you could go over to Desmos and you could create some various phase shifts and get some really cool designs. You could actually type in y cosine, and maybe you just want to use the sliders. Oh, I used an H up there. I guess I might not like that. Let's just a B. There we go. I never knew that. Now we've got a different color too, and you can change the colors in your settings. But you could come up with some interesting designs that way. Well, that's the bell. That's done. I'm done. You're done. Let's all